I'm Tomas Neubauer. I am CTO and co-founder at Quix, and previously I worked in McLaren, where I was introducing streaming into a motorsport. So why I'm talking about streaming and why I'm interested in streaming? Well, in F1, we were basically connecting F1 cars to the cloud, so people don't have to travel around the world every second weekend, and they can stay in the factory and build real-time decision insights. Unfortunately, the amount of data was so great, it was roughly 30 million values per minute per car, that none of the databases, none of the modern stack could save it and query it at the same time. And that's why we were forced to really get into a streaming tech and look at the Kafka and technologies around it. So I would like to do a little research here before we start. Who is used to work with streaming and know what streaming does and experiencing it? Okay, cool. Who worked with a Kafka before? Cool. And anybody tried Quix before? Okay. So, before we talk about the actual streaming, let's just do a little intro into it. So, I quite like the metaphor of a river. So, the batch is where you have flowers on your garden and try to water them, and you go with the bucket to the river to fill the bucket with the water, and then you walk to your garden and water them, and you do this in a periodic manner. Streaming is really putting a pipe between the river and your garden. So you get and process data piece by piece as they arrive immediately. There's no waiting for anything. Just as they arrive, you process them. That, however, requires a slightly different approach to quite common problems. So, for example, if you're doing an average on a piece of data, a historic or just a batch, it's quite simple and everybody probably knows how to do it. But when you have a streaming, you don't have the data to execute the average. You have to accumulate the state to perform the average on the data. So there's certain different approach to a lot of things that you already know from the batch. Now, so what is our approach? And what I'm going to show you today, how to solve real-time applications. So first of all, it's an adoption of microservices in data teams, and particularly using Kubernetes containers together with the Kafka to build scalable, resilient, and robust pipelines. It's also using a Python, because Python is, well, quite a popular language, first of all. Data scientists and data analysts using them. ML world really is living in a Python, and therefore I don't think it's fair to ask data scientists or people working with ML, for example, to use Java. So that's why we're going to use Python today. So let's talk about the most important concept in streaming. Sometimes it's called pub and sub service, and it's like a one-on-one building block of everything. So the idea is that you have on the left input topic, which serve the input request to your service. That could be a data from IoT device, from a sensor. That could be a financial transaction coming from a transaction gateway, for example. And then in the middle is your compute. You load this input request into memory. If it's Python, it's in the Python. And you do whatever you want to do. You filter data, you normalize data, or possibly you call ML model, or you just change the schema. And then you publish the output to output topic. Well, why this is a good idea? First of all, it's a very scalable solution, because that topic on the left is in reality created from a tiny topics called partitions. So you can have 9 partitions, 16 partitions, 32 partitions, and those would redistribute over the cluster in Kafka. So you can add more nodes when you get more data on input, and you can horizontally scale this to a very big processing. Then in the middle, we use Kubernetes replica system to launch the same container multiple times. And Kafka will assign a portion of the partitions to each instance. So imagine you would have 9 partitions on the left. In this example, every instance would get 3 partitions. So 33% of the traffic would go to each instance. Now, then obviously, when you're sending data to this pipeline, streams get redistributed evenly to those partitions. So this is how you scale it. And when you get more data, you just add more containers and more nodes in Kafka. Now, it's also a very robust solution for a number of reasons. First of all, in Kafka, you can replicate each partition twice, 3 times. So every message is actually sent twice to different nodes in a cluster. So if you have a hardware failure on one of the nodes, the stream processing is ensured. You also have an automatic restart in Kubernetes. So if you have a hardware failure in your compute cluster, or possibly a bug in your code, the service gets restarted, and because of the Kafka offset system, you will not lose any message. And if it restarts taking longer, Kafka would basically redirect the data to existing instances. And lastly, the queue system or persistence, temporary persistence in Kafka is good for 2 reasons. Number one is if you have a downtime in your processing, that could be you deployed a wrong version that doesn't work, you have hardware failure in your compute cluster, or possibly just a schema change or something. You will not lose any messages, any transactions, any data from your IoT devices. They will just stay in the queue until you solve your problem, and then it will continue processing. It's also quite handy to having spikes in your system. So imagine that at 7 p.m. something happens and you have 10 times more requests than you normally expect. If you have API-driven architecture, those services will just get longer and longer to respond until you hit a client timeout. At that point, you have a downtime and disruption in your system. That will never happen with the Kafka architecture. It will just take longer to deliver the response, but it will happen. So, before we go to the demo, what I'm going to show you today, you would probably, with a batch system, you would build something like this. So, I'm going to send today a data from my phone, which would be an IoT device for today, like a GPS, G4 sensor data, temperature, and you would send it to some database from where you would just extract it to processing with something like a Spark. Or you would use some in-memory database, for example, as well. But we're not going to do that today. We're going to do something else. So, here I have an empty workspace where I just have a WebSocket gateway service where I'm going to send data from my phone. So, I will start recording. And you will see, when I do that, the message will appear here. There we are. So now we're getting messages from my phone, and it's all happening real time. We can look at one of the messages, how that look like. We have a timestamp, GeForce data, etc. I can also click here, and sorry, the name of the stream is not updated. And here, if I can, I will get the GeForce data. And if I shake, you can see it's going up and down. If I put it on the table, it's stabilized again. Now, usually what you want to do before you start building stuff is to assess the data quality, actually get the idea what you're working with. For that, in Quix we have like a def temporary persistence here, which you can enable. And then all the streams are accessible here. And you can, for example, get exactly the same data into here. Now, this is how you just find your data, and then with this code tab, you just get them to Jupyter Notebook. And then data analysts or data scientists can assess what we're getting from the devices and get the idea what to build. So let's imagine we know what to build, and let's go back. And this is where we're going to build the first pop and sub service, as we talk in the slides. So I'm going to press here to add transformation. Here's the library where we have different open source templates and no-code examples. And today, I will use the empty template for Python. I will give it some name. And just tell where I want to read data and where I want to write the output. And that's it. So I want to subscribe to phone data, and I want to output it to GeForce Total. Cool. So we get a project, a Git project in Python. And what is important is those two methods. This is where all the magic gonna happen. You can clone it with the Git and use your favorite IDE. I'm not gonna do that today. I'm just gonna use this web IDE for now. So if I press run, it should work out of box. So it's just gonna read the data, as you see, directly from my phone. So let's do some little calculation, some new feature into the data. So because we don't have time for anything complicated, I will just calculate here a total amount of G-force applied to this device from all different dimensions. So you can imagine, like in a car, it doesn't matter if you're steering or braking, you have just 1 G available. So something like that. And what I have done here is basically just get the data frame from input. This is what the Quix SDK do for you. It just serves you a Panda data frame with the data. I add a new column to it and write it to the output. And that's it. So now, if I press start, there we are. So we see, because we have the gravitational forces of this planet, which is around 9, this is what we're getting. If I shake with this, we're getting higher values. Cool. So now, this super simple service is done. So let's deploy it to production so we can continue build our pipeline. So this is where we're going to use the microservice approach and Kubernetes as we discussed. So because this is powered by Git, here we have the changes, and I will tag them with a Git tag version 1. And then I'm going to press deploy and choose this version 1. The 0.2 core should be enough, and deploy it. Cool. So this is now being built into a Docker image, and then it's going to be deployed to Kubernetes with the Helm chart. We can click on it, and when it's running, observe the logs, CPU memory, etc. That usually takes around a minute. So what we can do next? Well, let's say that you want to detect when I have crashed. Let's say that I had this phone on my bicycle, and I crashed and want to notify someone. Well, we're going to build another transformation, but this time we're going to detect a threshold changes in data. And this is another microservice, another pop and sub microservice, but this time we don't have to code it because we already have it in library. So I'm just going to tell it it's a GeForce Total, and let's say that 15G is enough. Now here's the description how that service is working, and I'm gonna press deploy. Cool. So now we have a pipeline where we're calculating a GeForce data, as you can see here, and then we have a threshold detection for 15 Gs. Now this is it's probably too fast to read because it's catching up with the data, and now I think it's on the leading edge. So if I shake, we're getting alert. Amazing. Now, how are we gonna consume this alert? Well, there's many ways, but the simplest one is, for example, Slack. So I will go here and add a destination. Now, destination could be a database, Snowflake, Redshift. It could be your front-end application, your mobile application. Or in this case, it's going to be Slack. So actually this time, I will not just deploy it, but I will get the code as well. Because I want to just show you how our library works. So it's just a Git repository full of templates that you can edit by yourself. And we're going to do it here. So here we just need a Slack webhook. There we are. And now, if we wait for environment to spin up, we should get these alerts into a Slack. It's just going to write the messages to me on the Slack. I don't want to disturb my colleagues. So now we can see here it's installing all dependencies, and if you press run, there we are. And this is now catching up with the leading edge, so we're going to wait for that. Cool. So now if I shake, we have a new message in the Slack telling us that we have reached the threshold of 15 Gs from a number 4 to number 16. So this is how you just build more and more and more. And the good thing about this is that if you get more and more data, you just get more and more instances on each microservice we built. And if you have a downtime, as we discussed, the data are not lost. And the latency is around 40 milliseconds a round trip from phone to the cloud and back to the phone. So you can really build a human, you can build a real-time features that human can't notice that have been in the cloud and back. So I hope it made sense. I just want to stress that everything I did here is in our GitHub. So you can build it by yourself at home. And if you have any question or any problem, you can always reach to us by our Slack. And the last thing is that, yeah, with this QR code, you can get a free account where you can basically replicate exactly what I did, step by step, and yeah, do it by home. So thank you very much for coming here, and if you have any questions, I'm here. Thank you.